Okay, so everybody got the model as a reference. I'm going to create the process and the concept of linking a geometry into another one. In Revit, one of the main point sellers of Revit is this idea that all the information resides in a common element environment. And a common environment means a place in which all the information, your information, and the information from your consultants can be aggregated into a single federated list of information. And so linking is the process of connecting the data from your sub-consultants into your own model. And usually the way it works is that when we start a project in Revit, one of the first steps is to create a BIM execution plan that detail the rules of engagement in the modeling process with your consultants and as required per contract documentation. One of those requirements is the information exchange periods. What type of version you're going to be using, how often exchanges are expected, and when and how the files are going to be exchanged. There are different methods of doing that. You can send, on the most basic level, a file via an FTP site or a Google Drive, just like I did and shared with you guys. As the most sophisticated level, there are cloud tools like BIM 360 or Collaborate Pro or BIM Collaborate that will enable us to not only exchange information, but also edit, share information in the same common data environment, keeping the files technically in the same place and avoiding the need of doing this manual exchanges. So what I'm going to show you today is once we receive information from a consultant, we can retrieve that information and link it into our own models. But we're going to create a new model from scratch, and we're going to use the copy monitor to recreate levels and grids that matches the structural building without the need of building them manually. So let's start a new model. And then let's use the architectural template. The architectural template comes preloaded with a set of families that includes a couple of elevation markers. So we have levels, level 1 and level 2. You can disclose, just click the north elevation or any of the elevation to look at the level. And these two levels were part of the basic template. We are not going to need level 2 because we are going to retrieve it from our file. So I'm going to delete it. When you delete a level, remember when a level has the blue color, it's a visual indication that there are views associated with that level. And when you delete it, it's giving you a warning that these levels will be deleted as well. You just hit OK, that's fine. All right, and then I'm going to go to the site floor plan. And you're going to see that the site plan has 4 elevation markers. And then right at the center, it has 2 points on top of each other, a point that has a circle shape and another point that has a triangular shape. This is the coordinate. These are Revit coordinate systems. And let me pull a slide to show you what they are, what they mean. So I'm going to
Cesar?
Yes.
This is Jennifer. My coworker Gretchen is trying to get into the class.
Oh,
she said she was waiting to get in. I don't know if you see that.
Give me a second. I don't see the request, but let me invite her again from here.
Okay, thank you.
Copy link, copy invitation. I advise her to use, because I only have her work email, and if she's trying to log in using like a personal Zoom or a Zoom account that is not linked with her job, I think it's gonna have a hard time. So let's see. Okay, I just sent her an email. All right. While Gretchen finished logging in, I'm going to discuss the Revit coordinate systems. So I'm also going to switch in Revit. I'm going to switch to a 3D view. And notice how the coordinate systems are not visible here because they are part of a category that is switched off. To enable the coordinate visibilities, go to visibility graphics, type VG on the fly, and navigate through the graphic override to the site category. And the site category have subcategories that have 3 points. One is called the internal point, the project base point, and the survey point. By default, this is switch off in the default 3D view. And then you're going to see that there are 3 points on top of each other. So what does this means? This is in Revit. I don't know what it's called. I just this way. In Revit, we have the Revit space. The maximum allowable size for a project is about 20 miles. So think of it as a limited space of creation. This is very different from AutoCAD. AutoCAD, I think the extent of the project can be much larger. In fact, you know, if you want to model the solar system, you could do it in AutoCAD. But in Revit, the maximum allowable size, it's like a cube of 20 miles by 20 miles. Right at the center of this 20-mile space, there is what's called the internal origin. An internal origin indicates just the center of the Revit space. This point, it's visible. This is visible starting in Revit 2021. If you're using an older version of Revit, the internal origin wasn't even visible at all. You would, it was very difficult to track the exact location of the internal origin. In Revit 2021, that gizmo coordinate system of X, Y, and Z, that is the internal origin. Let me quickly, I'm going to go to site and just display the origin. I'm going to switch off the survey and the project base point. Okay, so these points is unselectable. You cannot pick it at all. it does tell you what is the orientation of their true north. So the red icon is X, green is Y, and blue is Z. And the internal origin main function is to allow users to use this same point as a coordinate system. A good solid strategy to have a consistent set of models aligned properly on space is to have and share the same origin. But that's not always the case. Sometimes projects start with different origins, and we still have the ability to anchor them even if they are in place in different locations. And so that's the next point. The survey point, which is represented by this icon and a triangle shape, it's a point that is used across all the different disciplines to align and anchor the models in a single place. It has coordinates that report distances based on north, south, east, west. Then it has a name. By default, the name of the coordinate system is internal. It is associated with the true north orientation, and it's a point that you can share, whose location can be shared between different consultants. Usually we start allocating placing the survey point in a spot in the project that it's a monument. Typically, sometimes more often than not, it's a geodesical survey point, like the ones you find at the middle of the streets or at corner locations in the city. And so the survey point is the shared coordinate system that we can modify. The internal origin, it's a point that is the center of the Revit space, but it doesn't report coordinates. We cannot share it. If we start from the same point using internal origin, it will be perfect workflow. That's not always true. If projects are misaligned, then it's best to start switching to survey points where we can import and coordinate the location of these coordinate systems. The survey point is usually associated with the ground level, the sea level. And the project base point is another point, which is usually called a building work point. It's like the stake on the ground that initiate the construction of the project. It's usually associated at the intersection of two grids. The project base point allow me to have two separate reference reporting reference elevations. The survey point, for example, reports elevation relative to the sea level. Project base point report elevation coordinates relative to the ground level. And so one of the properties of our levels is the ability to switch back and forth between sea level elevation driven by the survey point or ground level elevations driven by the project base point location. And so the project base point location is usually at a higher elevation than the survey point, and it's away from the survey point, and it reports coordinates relative to the location of the survey point. So these 3 points is what defines how we define our coordinate systems, and we define the elevation reporting of level heights. Let me check with Gretchen. Gretchen, you online? I see you calling in.
Yes, I'm here.
Okay.
Sorry that took a while.
Glad that you were able to call in. Welcome to the class.
Thanks.
Yeah.
I think it was my Wi-Fi, problems with Wi-Fi. Sorry.
Okay. So you probably call in later that in the class yesterday. Why don't you just give us a quick introduction about yourself so the rest of your teammates know who you are, where you work, how much information, how much knowledge of Revit do you have? What's your
Sure.
role?
Okay, great. Thanks. I'm Gretchen Mokry, and I'm a project manager at Herman Kohler Locus Architecture. I've been practicing architecture for, I don't know, 25, 30 years. And, you know, I know what Revit looks like. I've, you know, looked over people's shoulders at it. But this is my first time. I'm really finally wanting to be able to generate drawings. So my AutoCAD skills are no longer relevant. So I want to pick up Revit now at this point.
Awesome. Welcome, Gretchen. You probably have several classes to catch up with. If you want to catch up with us for this class, feel free to download the file in the file path that I posted in the chat panel. I don't know if you can see it, but let's see if I can post it again. Do you see a link in the chat panel of Zoom?
Not yet.
The Zoom controls have an icon called chat.
Yeah, no, I've got it open. I just don't see anything in there.
Okay, maybe because you call in late. Let me share it with you. Yeah. Get link. Copy again. Paste it here. All right.
Okay, thank you. Sorry, everybody, for bogging down the class.
No problem.
Okay.
No worries.
Okay. So again, three key things to remember. Internal origin is the center of the Revit space, of the 20 by 20 mile space, and it's used to align models that use the same point. If the models do not use the internal origin as an alignment point, they can use a survey point, which is also called the shared coordinates. Survey point is the anchor point that can be shared between models. That process is called enabling shared coordinates. We're going to go to a different class to do this. And then the project base point is an alternate coordinate system to define a different elevation so that levels can be associated with the ground level of the building rather than the sea level. If a file is bigger than 20 miles, you're going to receive a warning that looks like this in the lower right side. It says that the geometry in the file is greater than 20 miles, and this reduces reliability and undesirable graphic behavior. If you receive this message, do not ignore it because it's going to impact the performance of the file. An example is if you switch to a 3D view and things appear section randomly, or you switch to a 3D view and you don't see anything, things disappear. Or if you render and this render, it's stuck, or it's never finishes, that is an indication that there may be a CAD file that is creating a lot of problems. So if you see this drawing, it's best to exit the command and go back to the file and try to zoom to the extent of the file and try to make everything compact. All right, so this is the Revit 3D view. And now I'm going to enable, no, I'm just gonna leave it like that. What we're gonna do now is we're gonna link the structural model and recreate the levels and grids using copy monitoring. So the way to link a project is you go, to the Insert tab. and go to the manage links. And these are the different files you can link in Revit. You can link other Revit files. You can read the IFC files. IFC files stand for Industry Foundation Classes. Give me a second, I need to take care of this dog. So IFC, it's a new file form. It's a file format that stands for Industry Foundation Classes, and it's the file format that the industry is posing as the universal drawing and exchange source. And what that means is that different pieces of software can talk to each other using the same type of schema organizations. When we talk about exporting, I'm going to show you how we create an IFC from scratch. And then it also links different type of CAD files, CAD formats. You can link DWGs, DXF, which you can create with AutoCAD, MicroStation DGN, this universal SAT file, SketchUp files, and in Revit 2022, we can link Rhino models. So that's a new feature in Revit 2022. You can also link DWF markups, which is part of the Autodesk Revit Review file format. Point clouds. Point clouds are filed with the extension RCP or RCS. And the point cloud, you know what it all means. It's the file, it's the type of output that you create when using 3D scanning. It's a collection of points in space, sometimes with color, that capture the existing condition of elements, sites. You can link topography. A topography, it's a type of element you created by Civil 3D. This is a feature that has to be created by a civil engineer first in order to be in order to be added into Revit. It only works with cloud technology. You can link PDF. This was something new in Revit 2021. If you, for example, have a site that you want to just use as a reference and it's only in PDF, you can link a PDF. One of the cool things about PDFs linked is that they snap to the vectors if they were created from a vector-based software like AutoCAD. And you can also link images, and images, this is a cool way to, for example, if there are entitlements or permits that need to be part of a set and you need to place them on sheets, you can link them without loading them into the project. So the advantage of linking as opposed to import is that all the geometry, it's only cross-reference and it will be live updated when the link changes. So we're here to link Revit. I'm going to add a new link, and I will navigate to the place where this link lives. This was the my first building structure. I also share this file with everyone in the chat panel. So before we hit open here, check the options here, because it says that you can link elements using center to center, origin to origin, share coordinates, and project base point with project base point. the internal origin to origin and the project base point to project base point. It's a new feature in Revit 2021. So center to center, it calculates the geometrical center of everything that has been modeled with the geometrical center of the other model. If the models are empty, center to center means internal origin to internal origin. This would be a good way to get started a system of models. One in which you define the source of the internal origin and then you share with the rest of the consultants. And then you do what we're doing. We link a model origin to origin and problem fix. That's the easiest way of getting shared coordinates. This is something that you document in the BIM execution plan as a strategy adopted by the all the authors consultants. The other is by shared coordinates. This is the process by which we use the share point, the survey point, as the anchor point for all the models. This is a coordinated effort where the BIM managers define where this point sits in site and then share the information with the rest. Like here is how you do that. We're going to do an exercise later in the class on how you do that. This is the process of coordinate a shared coordinate system. And the other option, it's project base point to project base point. What it means is whatever the relative location of the project base point is, then these two are going to match. For this exercise, we're going to do internal origin to internal origin, one of the preferred methods of getting things aligned. I select the model and then hit open. And this dialog box give me the name of the link, the status, whether it's loaded or not. It has, this was a very important one. This is overlay reference type. And there are two elements here. You can overlay or you can attach. So if you're using AutoCAD, you're probably familiar with these terms. And what that means is if I have a model and then that model has a link, and then I set the link as an overlay, when I exchange the model to another consultant, Revit is going to only load it's going to ignore the links and it's just going to link the primary model. So if this is linked here, this model will not be carried on with the original one. But if we switch to an attachment, then Revit is going to attempt to load this model and all the attachment that comes with it. I don't recommend using attachments because it can create circular references. A circular reference is, for example, I have a model and this is the architectural model and this is linked here. And if I send this over another consultant and this consultant is the architect, Revit is going to attempt to link itself into the model, creating a circular references. So the best way to avoid circular references is just to use overlay. Positions not saved, it's a condition that happens when Revit detects that the files do not have shared coordinates. All right, and when I switch this to OK, then I see my model, my reference model in 3D. And if you look closely in the 3D view, notice how you can actually see in grayscale the internal point of the structural model. And this is a visual indication that our models are sharing the same internal origin. And that's good, right? This would be the easier and proper way of aligning the models. Another thing you're going to see is that when you select a link model, and this is something we did last class, I cannot select it. And the reason I cannot select it is because I have this control disabled. This is this one here. It's an icon that looks like a link with an arrow, which enable the user's ability to select or deselect links. If you disable that, then you can actually pick the link, but you could move it inadvertently. And if you move a model, you also move the relative location of the internal point. So when we link a model, one of the first things we need to do is to prevent users from moving it if the shared coordinates are in place. So you select the model, and then we're going to pin it. And then after you pin it, you'll also notice that you may not be able to select it. And that's also a part of the safety controls, this ability to enable the selection of pin objects. So when you select this, then you can select it, but when something is pinned, you cannot move it without Revit giving you an angry warning, right? Can move pin objects. When things are pinned, they are there to stay unless somebody manually unpin it. So pin it when it's in the right location. And now what we're going to do, rather than create level by level like we did last time, we're just going to do copy monitoring. Copy monitoring is a process by which Revit recreates certain type of geometry. Allowable geometry, it's levels and grids, but you can also copy monitor columns, walls, slabs. And for MEP, you can also coordinate fixtures and MEP fixtures. Copy monitor, let's start with the levels. So I'm going to switch to the south elevation, which discloses all the different levels in the project. Remember, we deleted level 2. So if you still have level 2, you can delete it. And there are 2 levels, one on top of each other. The current my project level 1 and the project level 1, they're on top of each other. So copy monitoring establish a relationship. It recreates level geometry, place it at the same elevation, the same level extent, and the same level name, and then establish a relationship between these 2 pieces of geometry. If one of them moves, then that's going to trigger a coordination review warning. And a coordination review is a Revit attempt to alleviate inconsistencies between copy monitor elements. So let's recreate the levels using copy monitoring. Copy monitoring, you're going to find it under the Collaborate tab. Yeah. And then you're going to find a tool called Copy Monitoring under the Coordinate panel. And so the options is you can copy monitoring elements of the current project between each other, or you can use elements with a link. So select the link is the second option. And then I'm going to select the project, the structural model. And as soon as I do this, watch this, the user interface change. I am presented with a copy monitor contextual tab. And then these are ways to select elements from the link file and the options to control them. So once you're in a sketch mode, this is a selection control mode. Then the only way to get out of this is if you click finish or cancel. So let's look at some of these options. In the options, you have these mapping. It's a grid of mapping definitions. that disclose what is the family information from levels and grids, and how are you going to map in it? What is the mapping equivalent? So things that you can copy monitor are levels, grids, columns, walls, floors. And so everything you see on the first panel, it's the families in use or families available to you in the link model. That's what it says, original type. A new type means what is the mapping definition in the destination file, my current file. You can do walls, for example, you can map the link walls with our walls. Anything that says new type is the definitions I'm creating in my model. And so when it comes to levels, there was an original type called a 1/4 inch head. This is the name of a family, and it's going to be created using my current one, 1/4 inch head. So that's fine. I'm not going to touch any of this. Here's additional copy parameters. For example, offset level gives the entity an additional offset in the Z direction. Sometimes structural engineers use that to reveal the top of steel. For example, if a structural engineer is copy monitoring architectural models and they know that the top of steel is 6 inches below the finished floor, then they consistently apply a value. You can add suffixes to your own discipline. Sometimes people put A for architecture. I never really use these settings, but it depends on the project. So on the level side, this is my mapping definition. I'm going to stick with the default. I'm just going to hit OK. And so I'm going to copy. So there are two things here. One thing is copy, another is monitor. Copy means find the original geometry and recreate it in my model. And monitor, it's just establish the location relationship between two objects. Monitor doesn't create new geometry. Monitor only establishes a reporting mechanism when two entities of the same type changes, and then you're presented with a coordination review. And so we're going to use copy to recreate level 2 all the way to parapet. But then we're going to use monitor to establish a relationship between level 1 in my project and level 1 in the structural model. We don't need to recreate level 1 from the link file because it's already in our project. So let's do the copy monitor first. So hit the copy tool. And notice that in the options bar, now I have a checkbox with the word multiple. This enables us to select multiple levels using Windows controls. So enable this checkbox. And then I'm going to do a crossing selection from level 2 to the parapet. Do not pick level 1. So do a crossing selection. Crossing selection is from the lower right to the upper left. And you're going to see that only anything that can be created as a copy will be selected. So notice how Revit select walls, select floors, select slabs. But the thing I just want to pick is the levels. Don't pick anything else. If you pick additional elements, you can filter them using this filter tool. And in the filter tool, you can just restrict your selection to levels. Filter tool. So I should only have 5 elements selected in the screen. And now I'm going to finish the selection. So just click the multiple selection button. It's this finish button in the options bar. And then notice how now I have, I have to finish. Well, I'm going to stop there. Don't finish this yet. But notice that now I have my levels in my floor plan, in my model. align with the structural ones in the background. All right, if you need me to repeat, just let me know if I should do that in the chat panel. Now I'm going to establish a monitor relationship between my level 1 in my active project and level 1 in the link model. So select the monitor tool. The monitor tool allow me to select level 1 in the link. So just go over level 1. Or you can also do across, yeah, just select it here. And then click again. So read the instructions in the lower left side of Revit, because it will tell you pick a corresponding element to monitor, and you just go and hit the level again. Oh, it says already monitor, so I already did it. It's a little less obvious, but you just have to click 2 times on top of level 1, and then our relationship will be enabled. The way you, I'm going to click to this modify tool here. These are ways to change existing relationship that you can stop elements if you need to. All right, this is copy and this is monitor. You just click the green checkbox. And when you do that, then copy monitor is finished. The way you're going to know something is copy monitor, it's because when you select that element, then you're going to see this icon that looks like a hard monitor rate. And the levels that display that icon, it's a visual indication that the object is copy monitor. Okay, so level 1 has a monitor relationship. I did not create one from scratch. And I have all the levels in the project. But check this out. All the levels here appear as black. What does that mean? That means that there is not a corresponding view in the project browser. And so I need to recreate those views manually in order to match the display of the structural model. So the way to do that, you go to the View tab, and then go to Plan Views, Floor Plans. And these are the levels that do not have views associated with them. I'm going to select 2, 3, 4, and the roof. Do not pick the parapet. And then hit OK. And notice how floor plans are not created as part of your project browser. I'm going to do the same with the ceiling plans. So you go to the View tab, Plan Views, and now we're going to create a reflect a ceiling plans. This is the list of the levels that do not have ceiling plans created. And the same using the control key, select 2, 3, level 4, roof level, and hit OK. And now I have my ceiling plans created accordingly. I also have all the grid lines created as a default. I'm going to move the north elevation marker. Just do a window selection. I'm going to move it away from the model. I'm going to move it right here. Yeah. And then when I switch to a 3D view, now you can see the levels we created in alignment with the structural model. One strategy you can use to visually differentiate what is the link model and what is your model is to apply a gray overlay to the view properties. Anything that is part of the link will be technically grayed out. And you can do that using visibility graphic overrides. So I'm going to switch to level 1 again, floor plan level 1, and then load visibility graphics, VG on the fly, and then scroll down. We're going to find go to the Revit links. This tab wasn't available to us before. This link only becomes visible to you when you link objects. And this is a way to turn on and off a link in the project. So if you click this checkbox here, that switch off the link in the model. Again, visibility graphics, Revit. I'm going to enable it again. And then notice also how there are two checkboxes here. One is called halftone, and another one is underlay. So a halftone applies a gray color graphic to any geometry that's brought in by the link. So I hit OK here, and then you see how the link has the same shade of gray. It's a visibility graphic override, so it's only applicable to these particular view. Meaning that if I switch to the model in 3D, then I have to build or embed this into the view templates. We want to talk about view templates next class. And so we have to apply that override to view by view or make it part of the view templates in order to get this with the appropriate color. Like you go to level 2, notice that it doesn't carry away because visibility graphics, it's a graphic specific, it's a view specific settings. All right, so what if I have 25 levels? Do I have to do this manually over and over, view by view? That's a lot of things to coordinate. And so I'm going to give you an intro to the view templates. A view templates, it capture the visibility graphic of the view into a common definition that can be imported across multiple levels at a time. And if you need to tweak elements of the graphic properties of a view, you just change the view template definition and it's going to apply through all of them. I'll give you an example. You have a structural model, but you don't want to display the the hatches that are coming from the structural model. You can tweak the view template one time and disable the visibility of all the hatches for the floors, for example. And then you can apply the same definitions to multiple floors in a single step. If you need to continue refining the visibility graphics, you change it at the template level, and then that's going to update accordingly in your project. So let's create a view template. And this is fundamental, guys. View templates is the functionality in Revit that controls how your construction documents, your final sheets are going to look like. And it captures the way your company display the scope of work that is associated with your contract. And so having a robust set of view templates, it's fundamental for Revit to display correctly the information needed in the final set. In fact, view templates are like sacred, sort of sacred. I mean, you're actually compromising how a thing's gonna be displayed in the final sheets. So to create a new view template, let's say I want all these links to appear the same way across all the different views. We don't want to do it one by one, so we're going to create a view template. So what we do is in the view template, we're going to create a new template based on the properties of the current view. So hit the second option under the View tab. And this is going to be called, let's say, the typical construction plan. Construction plan. This is the name of the template. And then you're going to be presented with the visibility graphics that are associated with the construction plan. And so this checkbox right on the end, on the final column, it's a way to include or exclude visibility parameters associated with that category of visibility graphics. So the visibility graphic overrides are all of these, remember. Model, annotation, analytical import, all these are the visibility graphics. If you hit the edit button, it just open the visibility graphic override. In fact, so these tab correspond to this tab. Annotation categories correspond to this tab. Analytical, imported, filters, and Revit links. And I think something similar, the closest thing in AutoCAD may be the layer manager or layer state, that's how it's called. So this is something similar in that we create a definition of visibilities across different categories of objects. And then we capture that inside a template and apply it to a view. So you can choose to include or exclude certain categories. For example, maybe you want to use the same templates, but leave the user the ability to choose his own scale. So you can exclude the view scale as part of the view template. I'm going to include it for this exercise. Another thing I'm going to change, I'm going to make sure that the detail level is switched to fine. And this is going to be part of the template. And make sure that the Revit links, it's also included. And then edit the button next to Revit links. And I'm going to make sure, just double check that the Revit links always display halftone for this template. Okay, so I'm going to hit OK here. And I created the template, but that hasn't been applied to the views. And so to apply a template to the view, select the level. And then notice what's going to happen here. This is the view controls. And the view controls are all, there are ways to change the instance properties of the view. Now, when I apply a template to a current view, see what happens. Apply the construction plan template. I pick that template from the panel and hit OK. And then after I do that, let's see, apply template. This is another way to do it. You do apply template properties and select construction plan and then hit OK. Or you can do it, view templates, apply template properties to the view, construction plan. OK. Why didn't it show? It's supposed to lock these guys. Let's see, in the properties. Oh. Okay, I got this. I got that reversed. The apply template properties to a view inherit the parameters of the view template into the view, but it doesn't lock it. In order to lock users from making changes into the view properties, we have to use the instance properties. So under the property windows, if you scroll down, you're gonna find the view template in the view properties. The default value, it says none. we're going to change this view template and we're going to change it to construction plan. And now when that happens, then all the values of the view control are grayed out. So in other words, Revit doesn't want the users to make individual changes to the view because they are locked by the view template. And so we have to apply these properties to multiple views. Let me pull this here on the side. Okay, to apply templates to multiple levels, Control select all the levels, except the site. We don't need the site to have that. Control select all the floor plans. And then once you have them selected, go to the view template property and apply the construction plan. And now, after you do that, every floor plan is going to follow the view template that we defined. And the individual controls, the individual view controls are going to appear locked. And if you see this locked, that means that there is a template applied to the project. So make sure that you apply it appropriately, the different templates. Okay, are you with me here? Any question? Again, a view templates, super important concept. If we need to change the view template, just go to the manage view template and make changes in it. Say, for example, this is just an example. You don't have to do this. If you just watch, I don't want the columns to appear in any view. So all I need to do is to change it under the overrides Revit links. So what this is going to access the link visibility graphics. Sorry, I need to pick the right one. I need to pick the construction plan in this panel. And then I need to click the visibility graphics Revit links. And here I can selectively display elements by category using this button that's called by host view. When you click that, then you'll be presented with the link visibility graphics. When you see this word by a host, what it's saying is that Revit is going to inherit the view properties according to the active project. But I can manually override that and say, for these templates, for the construction plan, all the model categories will be override by a custom setting. So you need to switch this to custom. And then switch off the structure, ST, structural columns. And then you hit OK here. OK, OK. Now notice how the template freezes the columns for the link, and that applies to every link, to every view. So I'm going to do it again. The way to enable or disable the visibility of objects in the link file is via view template. The view templates apply to this view. And then if we need to change it, go to manage view templates. Then go to select the template you want to edit. Display the Revit link visibility graphics. Change the display settings to custom settings. this is going to disclose the link visibility graphics. Change the overall setting to custom, then switch to model categories. Model categories, we will override the view using custom settings. These are the visibility graphics of the link. And I scroll down to the structural columns and disable it. Disable the visibility. Hit OK, hit OK, hit OK. And now the columns in every level that has that template will be switch off generally. And so we do this a lot with templates and link files. You're usually going to receive a file from structural. There is information in structure that you don't need to display, and vice versa. The structural engineers require certain geometry from the architectural model. They don't need everything about the Revit model, especially finishes and things like that. And then they switch off using the templates the visibility contained by that link. All right, I'm gonna do this. I don't know. Let's return the view template to display the columns, because for this project we need them. So again, let's go to view templates, manage view templates, construction plan, Revit links, custom settings, and then the custom settings, I'm gonna return them by host. And when you do that, it's going to remove all the individual overrides, and it's going to match it the architectural model. And hit OK, hit OK, hit OK, and I return the columns back into place. All right, so let's we copy monitor the elevations. The elevations and the views are in the project. Now let's copy monitor the grids. Right now, the grids are shown in gray color. That means that they are part of the link. When you select it, you can only select the entire link. So to copy monitor the grids, let's launch it. Go to the Collaborate tab, and then hit the Copy Monitor tool. And pick the select option in the drop-down list of options in the copy monitor. Select link. And then select the link. Right after you click, you will be presented with a contextual tab. And we're going to copy the grids. So switch to copy here. And then use the multiple checkbox in the options bar. And do a crossing selection. A crossing selection of everything on the screen. Revit is going to select the things that it can copy monitor, but we're only interested in the grids. So we need to filter out the other elements. To filter our elements, use this filter tool that's right next to the cancel button. And in here, filter out the structural columns and the floors. We're only interested to recreate the grids. Now that I have the grids selected, I should only have 10 elements in my current selection. Finish this selection. And then here's a weird thing. You need to go back to the Copy Monitor tab and then finish the command. And now the grids are my grids. The architectural grids are created on top of the structural ones. And they are individually selectable. Copy monitor can be disabled. Like if you are no longer want these two elements to talk to each other, then select an element and hit stop monitoring. But right now, any changes in the structural model is going to trigger a coordination review. Revit is going to detect that there's been a change and can suggest a solution. There's a whole exercise about coordination review that I have prepared for you later in the class. Okay, so this is how we recreate levels and grids from a structural model. They inherit the same location, extent, and ID. And these processes are useful, so you don't have to create them manually. The relationship created, it's crafted using this using copy monitoring, and you can see copy monitor elements by selecting the elements and looking at this icon, the hard monitor icon. Okay, any question about copy monitoring? All right, now that we have the levels and grids, I'm going to show you a trick about how to copy geometry between links and architectural model. For example, here the link model does have the ground level slab, and it has these slopes. If I need to recreate that in the architectural model, the slope method is to retrace all the boundaries. But you can also select an element in the link file, copy to the clipboard, and paste it exactly in the same place. So the way to do that is that I'm in a 3D view and hover over the link. Just hover over, don't select, just hover over and hit the tab key. So hover over the ground level, move the cursor close to the edge of the slab and hit tab. Oh, actually you have to select it. Select the element and then hit tab, tab. Tab enable you to click select elements in the link file. For example, this column, hover over, select it, and then hit tab. Now I have selected just that column in the link file. Let's do that for this lab. Tab, selected. And I'm going to copy to the clipboard. The copy to the clipboard, it's in the available to you in this location. You can also do Control C. And then hit paste, align to the same place. And so the same slab and the structural element is going to be copied exactly in the same location as the architectural one. And now this is part of my model, and I can edit the boundary and change the architecture if I need to. So bring things back and forth between links when needed. Again, only when it's justified. Like sometimes you don't want to have redundant information, and certainly you don't want to confuse consultants by having two elements in two different locations. Floors sometimes live in two different models. There's an agreement where the architect tender the ownership of the edge of slab up to end of a schematic design. And then during DD, structural is the owner, and then the ownership switch. And then we use visibility graphic to display or not display the redundant objects. Okay, I copied this lab in the project. I'm also going to copy paste the sloping surfaces. There are two of them, so we can practice. So tab, select the floor, copy to the clipboard, and paste to the same place. And I'm going to do the same with the other slab. Hover over, tab, select the floor, copy to the clipboard, and paste in the same place. All right, so if we switch off the links and visibility graphics, and I go to Revit links and switch it off, these are the copy paste slabs from the link file. And I'm going to undo just to display the entire link. All right, so let's save this file, save it as a new project, and we're going to call this My First Building Architecture. And in the real world, we follow naming standard for the different files. Each project has a different naming standard that needs to be captured by a BIM execution plan. And then I'm going to start the discussion of the curtain walls. So I'm just going to get started in a ground area next to the project. And let me start this here. All right, I showed you this slide last time, but this is a review. A curtain system is a system family, meaning curtain systems as an assemble that cannot be saved as an RFI. But they are made of different components. You can subdivide a gigantic piece of glazing into different sub-panels. The grids, you can create the grids on the vertical or horizontal across the entire surface, or you can also create segments of a grid in a specific panel. I'm going to show you how to do that. You can modify the location of the grids by selecting them individually and then using the temporary dimensions to shift its location in the horizontal or the vertical. Then find a mullion profile that is appropriate for your project and for the product manufacturer, and extrude it along the grid locations. And then swap panels accordingly to meet design intent. Panels can be swapped with other wall types. In this example, the panel was swapped with a brick wall. And doors are also a specific type of panel types. These panels need to be loaded into the project before they can be used. So in Revit, you're going to find these 3 different curtain walls available out of the box. You're going to see the curtain wall 1, exterior glazing, and storefront. And the way these families are named has very little to do with the way they actually perform in real life. But a storefront, it's a parametrically created assemble. The size of the panel and the distance between the grids are the response of rules applied in a dialog box type properties. By default, Revit pin all the panels and all the grids. And Revit is in control of the distribution of the panels according to layout rules. This is the easy way to create a storefront, but it only creates a regular pattern. Curtain wall 1 is the custom method of creating a storefront or a curtain wall. In this method, you create a gigantic piece of glazing, and then you have to manually place each grid in the horizontal or the vertical. And you have to also create the mullion. This is the longer method of creating a curtain wall, but it's the one that gives you more flexibility because you can customize the panel patterns in the horizontal and the vertical. And then there's another one called exterior glazing that it's only recommended to be used in roof glazing conditions. Like if you have a roof, glazed roof, you will do that. There's another method. This is not a part of the wall tools, but this is a different category, curtain systems. These are derived from a mass object phase. We're going to talk about that later in the class. Well, let's look at these options. Let's do the easy one. So here on the left side, I'm in a 3D view. Just pick an area outside of the project. And let's start the parametrically created storefront. So I'm going to bring my property windows, stack it here. All right. So to create a curtain wall, you go to the architectural tab. It's just like creating a wall. Now, this is the type selector. In the type selector options, you're going to see basic walls. And then if you scroll down all the way to the bottom, then you're going to find another group of walls called curtain walls. This is a different category of objects. And those are the 3 methods that are available in the template. So pick the storefront method. And again, I'm going to type it because this is important. If you choose the storefront method, then this is the auto parametric. And all the properties are defined via property dialog box. Dialog box property. So we don't technically interact with the grids and levels and mullions. And this is the easy method. Easy. All right, so I'm gonna click. This is my first click. This is my second click. Again, the ordering of clicks, it's important to understand the parameters. So the first click is called border 1. Don't ask me why. And the second one is border 2. And so you're going to see in a second why. So this is my second. I'm just using a random location. I'm going to do this at 0 degrees, maybe 40 feet. And voila, you don't have to do anything. The storefront is created right after you finish the second click. And if I want to display the color of the panels, switch this to a shaded view. Now, this is a storefront family. And when you open the type properties, these are the distribution rules. And so the vertical grid has a maximum spacing of 5 feet. So the typical distance between this is 5 feet. 5 feet maximum. not going to be exactly 5 feet. Revit is going to do the math. It's going to subdivide the distance, all the distance up to a maximum spacing of 5 feet. The horizontal grid is a fixed distance of 8 feet. And so it starts from the bottom, 8 feet, 8 feet, and then there's a residual panel at the top of it. The different mullion families are divided by vertical and horizontal. So in this drop-down list, you will choose what type of mullion you want to apply to that type of mullion. So remember the word border 1, border 2. So vertical mullion, the interior types are all of this, everything that is inside, interior, 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 interior. The same family is applied across all the elements in the interior side, the vertical ones. Border 1 in the vertical side is the first click. So this is called border 1. And that is the profile for that border. Because why border 1? Because it was the first click when we created the project. And this is border 2. That was the second click. And the vertical profile is that one. For the horizontal is something similar. The interior types for the horizontal are this and this. The border 1 family, it's the bottom one. So this is the sill. And the border 2 is the one at the very top. And so depending on the manufacturer, depending on the height, depending on the adjacent attachment assemble, different mullions have different profiles, you know this. And so you can model different profiles according to the function that they perform in the system and apply it selectively to different type of mullions. All right, and then at the very end, notice that Revit also organize the model elements using an assembly code. This is OmniClass. If you are familiar with classification systems, you are familiar with master format, unit format, and then more recently, the CSI, the Construction Specification Institute, also is using unit format as a way of classify the digital information and use it for pricing schedules. These are by default associated in the family editor. I'm not going to get much discussion into that for now. But these are the type properties of the storefront. Now, if I need to make changes to this, remember, we need to apply the new changes in a copy of the type. Because if I change the properties of this storefront, I'm changing it. I'm changing the original definition. So I'm going to duplicate it I'm going to duplicate it and rename. So duplicate it, the storefront. I'm going to call this type 1. And my type 1 is going to be, is going to have a vertical grid of 8 feet as well. And no, let's do it 5. 5 is fine. Maximum spacing 5. And the horizontal grid is maximum spacing of 5. And then let's say all the interior borders are going to be smallish 1 by 1. You can select it using this drop-down list, or you can just select the value, Control C to copy the value, and then Control V for the horizontal ones. Oops, not that. Let's just use the drop-down. So I am changing type parameters in a fresh new type. making sure the original remain untouched. Then hit OK. And now I have a different storefront with different rules. Part of the instance properties of curtain walls is also the ability to rotate the vertical or horizontal grid. Say I change the vertical grid to have an angle of 45. And this is what you get. You can also change it in the other direction. Change the horizontal grid to an angle of 45 as well. And now you have a rotation of the grid. You could create a circular storefront as well. So if you go to wall again, architectural, choose the storefront type 1. This is the one type I created based on an existing one. And you can create a 3-point arc. 1, 2, and 3. And this is a circular storefront. It is faceted. I don't think using the curtain wall you can get perfectly round panels, but there's a workaround about that. When we talk about custom families, I may show you how to do that. And also you can edit the profile of walls. I'm going to create another wall here using the same type, but now I'm going to edit the profile. Select the wall, edit the profile, and I'm going to do, let's say, a rectangle, an opening inside another opening. This is just a rectangle, a sketch rectangle inside of the other one. Click the checkbox, and now I have a wall opening. Elements in Revit. This is the automatic method of doing. This is the type properties. I think it shows. Oh, the borders are 1, and interiors. I mean to do the opposite. So the interiors need to be 1 square. Let's do them all 1 inch square. Now I have them all in the same location. Now notice if you zoom in how their panel, it's a little off away from the mullion, and that is a type property too. So if you hit the edit type, is that right? Let's see. It is. That is a property of the panel. So I need to tab select the panel, edit the type, and change the offset back to 0. And now it's going to get back to, let me do it again. I think I do it too fast. To fix the alignment of the panel family, hover over the edge of a panel. When you are touching like the edge of the panel, hit the tab key. The tab key select the nested family. The name of the family is the system panel. And when you edit the type, you can change the offset to 0. It's going to give you a warning that things are going to change, and that's fine. Now I have all the panels center along the system center line. Mullions can be individually changed, but they need to be unpinned. For example, if you decide that the top curtain wall mullion needs to be different, you can unpin it and switch the panel by a different one, like 2.5 by 5. But when you unpin a parametric curtain wall, then you lost the ability of the curtain wall to control that. Let me give you an example. I'm going to change now this type the type properties and say that the horizontal border 2, I'm going to make it 5 by 5. Notice how it changes to all the horizontal except the one that I unpin, because when I unpin, I disable Revit ability to control these mullion parametrically. So don't unpin elements unless they are absolutely necessary. So we're going to build a curtain wall around the skin of the project. But this is the first method, the method of doing it parametrically. I'm looking at the clock, and I think I'm going to stop here because I have this thing to do later. The second method, we're going to review next class. So it's going to be the custom created curtain wall. And then we're going to use this method to wrap the building in a curtain wall system. So save this file. And yeah, next class, we're going to review the second method of curtain wall. We're going to focus on the model. And then we're going to talk about materials and finishes. So for those of you doing interiors, this might be of your interest. All right. Any question, guys? Sorry, I have to wrap a few minutes earlier. Hope you don't mind. All right.
Thank you, Cesar.
Then I'll see you Thursday, guys. And I'm going to stop the live recording.